Hi everyone, my name is John Humphires from the Crane Industry Council of Australia, and my presentation today is about crane safety in the crane industry as part of the International Auditor Symposium run by Exemplar. So just a little bit about me before I get started. I work for the Victorian Tasmanian branch of the Crane Industry Council of Australia, and I'm a safety liaison officer. Previous to this, I worked in the automotive industry for a number of years, and I've moved across into the crane industry about 2.5 years ago. And some of my other interests are bike riding and my car. So this is the company I work for. It's a private members association. All the members that own cranes, the crane companies around Australia, are all members of this association largely. And we are a non-for-profit organisation that is put in place to serve the membership and act in their interest, and also to I guess, be a voice in the industry and ensure that safety is maintained. So my role is partly funded by a grant which comes from Incolink. So this role's been in place for a number of years now, and there's a number of positions that have been created by Incolink, safety related within the industry. A lot of them are in the union. However, mine is unique in that it's part of the industry itself, not the union, and I represent the crane owners and the crane companies, not the workers so much. However, all the safety work I do relates to everyone, but that's just the way my current role is structured at the moment, and a big part of that is from Incolink. So the Crane Industry Council of Australia, the mission is the authority for the crane industry, and the vision is a safe and progressive crane industry. So it's a national peak industry body since 1979. We've got about 600 members. The members include crane owners, crane manufacturers, rigging equipment suppliers, service providers, maintenance and training. So it's sort of a whole cross-section of the industry are all generally members of SICA. And the sectors include mobile cranes, tower cranes, and vehicle loading cranes. So we'll go into crane types in just a minute. But the main point we want to emphasize here is that we sort of act for basically anyone that has anything to do with cranes. We are, I guess, the peak body that is designed to help that. So types of cranes that are out there, this is a bit of Cranes 101. The tower crane, there's a lot of these at the moment, particularly in Melbourne and Sydney. There's actually more cranes in Melbourne and Sydney than there are London, New York and LA at the moment. That gives you a bit of an idea of how much construction is going on in the eastern side of Australia at the moment. It's a huge amount of residential and commercial construction going on in both the CBDs and the suburbs, and tower cranes like this are very common at the moment on building sites. The next type of crane is a mobile crane, which basically lives in a depot and drives on the road with a maximum speed of 80 kilometres an hour. You get a whole different cross-section of these cranes, anything from small jobs to precast panel erection, lifting swimming pools and spa baths into residential houses, putting air conditioners on the roof of buildings, to larger scale projects like building bridges, lifting concrete beams, and all that sort of thing. And this type of crane will assist in erecting the tower crane that I showed you on the previous slide. So you actually use a crane to build a crane. The third type is what's called a crawler crane. So this is much larger and has to be completely dismantled and shipped on the road on trucks. Basically semi-trailers will carry a crane like this to and from the site. So a crane this size might have 30 trucks that are needed to take it away bit by bit, and might take up to 2 weeks to set up. So it's obviously for very big jobs. Very heavy loads with a very long radius. So you need a very large crane for that. A lot of these are used on wind farms, as well as erecting heavy bridges. This is what's called a pick and carry crane, or an articulated crane. It's designed for small jobs, like lifting things into place. And the unique feature of this crane is that it can pick up a load and drive with it and move it. Whereas other cranes, they can really only move a load, sort of between 20 and 30 meters, because the crane is set up on the ground and based in one spot. Whereas this crane can basically pick a load up and move it as far as it wants, slowly, but surely it can lift a load that's very heavy and travel a long distance with it if it's needed to be moved. The next type is called a rough terrain. So this crane is usually for very uneven ground, building sites and mines, and that sort of thing. You need to float this on a truck bed. You can't drive that on the road due to its peculiar dimensions. It's unsuitable for road travel. Unless it's on a building site, it can drive, but generally a crane like this does not get driven on the road network unless it's very special circumstances, like the road is being resurfaced, or there's works going on, or it's involved in the construction of a bridge. Otherwise, this crane you won't see on the road. So that's a snapshot of what types of cranes are out there. In terms of what they are actually used for, by far the biggest sectors are general construction and infrastructure, which make up about 80% of all crane usage. So you can see obviously some familiar pictures there of an elevated railway, or a sky rail as it's known in Victoria, being constructed. And when we say general construction, we mean basically any type of building or structure. And it could be any component. It could be the walls, the windows, the air conditioning, machinery that needs to be lifted during the construction phase. And you've got renewables, which are wind farms, which are very common at the moment. However, still only 7.5% of the total crane usage, given that there's a whole lot of other crane usage going on, even though we are building a lot of wind farms in Victoria and other states of Australia as well. Petrochemical needs cranes, but due to the small number of plants around Australia and the amount of time cranes are used, it's quite sparse and spread out. But when cranes are needed there, you'll get a lot of cranes in one place, but then they won't come back for 6 months or so. So the petrochemical industry needs cranes, but they're required for a very short amount of time, and then there'll be a large delay before they're needed again. And the mining industry is another obvious one. Again, there's quite a few mines in Australia, and there's quite a few cranes there. However, they're mainly there for shutdown work and for, I guess, isolated periods of time, whereas the infrastructure and general construction side will have cranes basically daily coming and going the whole time, which is why that's the bulk of crane usage in Australia and sector allocation. So why does my role exist? My role is a safety role, and if cranes didn't have accidents or safety issues, my role wouldn't exist, but unfortunately they do. So my job is to communicate safety information and, I guess, provide members of the Crane Industry Council with the latest standards and industry expectations, alerts, all sorts of communication from WorkSafe Victoria and the CFMEU, feedback from construction sites. So what we see on the screen now is an example of a crane accident in Richmond in Melbourne that happened a few months ago, where the crane was actually damaged by the wind. It was not stored properly overnight, and a storm came through, and the boom of the crane is actually bent backwards and is in danger of falling, and is in a very precarious position in a very dense residential area with a high traffic volume directly underneath it, including pedestrian, trams, and also cars. So this was a very high profile incident that occurred, and there's a lot of debate about what went wrong as to whether the crane was serviceable at the time or whether or not it was improperly packed up and whether it was operator error. So the findings are still yet to be made official. However, they're the two main issues that are the probable cause of the incident. Unfortunately, there were no fatalities, but it could have been a lot worse than it was. There was a massive disruption to traffic. I think the city block was shut down for 3 or 4 days, which cost a lot of money. So next one is a recent incident in Melbourne where a crane has tipped over backwards. The preliminary findings were that the crane was lifting in a load, and it became apparent that the crane was possibly not in the best position, and rather than move the crane, the driver tried to operate in a less than ideal position, and unfortunately the crane collapsed. This is still under investigation, but this is an example of a crane tipping over in a residential area. So the danger there is severe because the house next door had people in it at the time. So obviously, like anything crashing through a roof, the potential for disaster is enormous. And fortunately, in this case, there were no fatalities as well. But you'd put it down as a serious near miss. The next one is an older incident which occurred some years ago in Melbourne, resulted in a fire. Cranes like this have got diesel motors in them, and I believe there was an oil leak, which then caught fire, and it burnt for some number of hours until the crane actually collapsed onto the roof of a nearby building. So this is the uptake from this was fire suppression units were installed in cranes like this. So in the event of the fire breaking out, the driver has got some hope of putting it out before it spreads. In this case, the fire's already spread. I think you'll find the driver's long evacuated the crane by now. So that was the main outcome from this incident. Some cranes are electric, some are diesel. This is an older style crane. They're still quite common in Melbourne. However, there's now a lot of measures that have been put in place to prevent this from happening again. So this photo here is demonstrates a ground pressure failure. So the crane is tipped over, like the second incident I showed you. In this case, the ground has actually given way. You can see that the corner of the crane that is dug into the ground has actually caused it to tip over. So this is a very common style of incident as well, because you might do everything correct setting the crane up. However, if you have improper ground conditions, the crane will sink into the ground and tip over, even if you're doing everything right with the crane. If you're not on stable ground, they can quite easily tip over. And obviously, the effect of incidents like this are quite severe. When a crane falls over, it's quite catastrophic. There's a lot of weight in cranes, and they're very large. So when they fall over, their capacity to hit things and knock other things over and cause damage is huge. And obviously, a person compared to the size of a crane is almost like the size of an ant compared to a person sometimes. And just the sheer scale of it means the potential for damage and loss of life and injury is huge. So what causes crane accidents? We've obviously seen some examples of the accidents. So my job is to look into what's actually causing them and to examine the incident data that comes through and try and determine what the main drivers are and what sort of safety information needs to be circulated in order to prevent these sorts of things from happening in future. So the most obvious way a crane can tip over is overbalancing. So you can see here, the 25-ton load is pulling on that side of the crane. It's supported by 4 outriggers, and the crane has its own centre of mass and counterweight system that acts on the other side. So there's a balance point or fulcrum, which is the base of these 2 arrows here. And we've got 2 different moments acting against each other. And one of them is the weight of the crane pulling down, and the other is the weight of the load. So it's a typical balance. And the crane is designed to only go to 75% of its capacity. So you should never get to this point. What happens is operators misuse the crane, and that's when they tip over. So if you're operating the crane correctly, this should never occur ever. But obviously it does. So it means that there's a human element, whether it be ignorance or recklessness or complacency, that can cause a crane to tip over. I'll get into these causal factors in the coming slides. So that's the first way you can have a crane accident. This is another example of it, what it looks like in real life. So we've seen the physics behind it, of how it can happen. And here's the real life example. Obviously the crane's fallen onto a house, which is a highly dangerous situation. But when you look closer at this one, you can see there's an incident with the outrigger sinking into the ground. So the ground's actually collapsed, which has caused the crane to tip. Now, you only need a small amount of movement on the stabilizing arm or the outrigger. If that drops by, say, a foot or maybe a meter, that'll create a huge amount of movement on the end of the hook, obviously, because the crane's got a very long boom. So you don't need a big failure in the ground to cause a huge disruption to the crane stability. And obviously the consequences here are quite catastrophic and dangerous, and all because proper ground conditions haven't been recognised here, or there's the lack of an outrigger pad which stops this outrigger from sinking into the ground. And that's obviously the direction the crane's going to go as a result of that outrigger arm sinking into the ground. Now, another huge cause of accident is contact with electrical hazards. There's an entire government department called Energy Safe that's been set up to tackle this incident. It's not just cranes, it's construction equipment in general and excavators and all that sort of stuff that can have problems hitting electrical assets. It's very easy to do because when you're building something with a crane, you're looking at everything else but the overhead power lines. This is one of the most common incidents in the crane industry. And the results generally are quite severe due to the high voltage in the power lines and the huge amounts of electrical potential energy that is suddenly sent directly through a metal structure, being the crane, that has a human being inside it. So the first thing to happen is usually some sort of a fire. Generally, as the electricity reaches the ground, everything it passes through gets rather hot rather quickly, and the first things to go are normally the tyres, which are flammable, which doesn't help things. Now, rubber is generally a good insulator. However, there's steel belts inside the rubber, and with a high enough voltage, you'll find that the tyres will start to combust and catch fire. And the other issue with an electrical impact is the ground around the crane is energized as well. So often when the driver exits the crane, you can have the electricity jump from the crane and arc through the driver and electrocute him as he exits the crane. So it can be very dangerous. Here's another example of a vehicle loading crane contacting power lines, and you can see the wheels have caught fire on this. So in a scenario like that, generally the situation is still what you would call live, where there's still live electricity. So it's not just a singular incident, it's actually a dangerous situation that can last for a considerable amount of time before the electricity is cut off. So if we step away from electrical fires at the moment and electrical contact, another obvious incident that can occur is when you're picking up something with a crane, how easy it is to, I guess, drop the load. What we see here is the rigging, which is the ropes and hooks and systems used to actually lift the load and secure the load. So this load is slung in two different ways. The left side is the correct way and the right side is the incorrect way. The reason being the center of mass of the load is indicated by the circle, and the way slings and rigging work is you have a triangle here, and it's called the triangle of stability. So generally, if you've slung the load with the center of mass inside that triangle of stability, the load is what's called stable. Whereas here you can sort of picture this load falling left or right due to the size of this triangle and the fact that the center of gravity or the center of mass of this load is above that triangle. So it's stable in one way, but unstable the other way. If we explore that further, you can see here we've got two axes of rotation. The red axis is the danger one. So this means that rotating around this red line, this load can fall left to right. Whereas the green axis is the stable one, which if you turn 90 degrees, you've got a much taller triangle which runs all the way up to the hook. So the load can't really fall out around the green axis due to it being secured either side by this rope. However, the red axis, axis 2, we can see here that the load could easily fall left and right out of that. It's quite a difficult thing to explain by words, which is why the picture clearly shows the two different axes of rotation and the two different directions the load can fall, one stable and one unstable. So a real life scenario here is shown where we can see this large heavy mass is starting to rotate to the left. And we can see here we've got what's called a lifting beam, which is literally like a seesaw. So we can see that's tilting and the load is falling onto the left-hand side. So the top picture represents that, and the bottom picture shows what should have been done, which is having a triangle up here, which means when you transpose that down, the center of mass is inside that triangle, shown here. Whereas the top picture, you can see the center of mass is above the triangle of stability. And that is potentially a dangerous scenario. Now, what's interesting about this is the load is falling to the left. If you look on the other side here, we've got a big triangle. So that means the load is very stable in that direction. So the load is not going to fall, I guess, if you look into the screen and away from the screen, the load is not going to fall in that direction. It's only going to fall to the left or the right, and in this case, to the left. So that's an example of a bad rigging practice, which still goes on. People still, even when they're lifting very loads, get it wrong. And you can just tell that it doesn't look stable. So the summary is, when you're lifting something, there's your triangle of stability. The center of mass needs to be inside or below it. And here we can see it's above, and that's unstable. And here we can see a slightly different version of the first example, but we see the center of mass is still inside the sling, and the load is stable as we're inside the stability of triangle. So what research has been done? Obviously, my job, I see day-to-day incidents that happen, but some work's been done by universities, in this case RMIT, causes of fatal accidents involving cranes in the Australian construction industry. So this is obviously a very useful and powerful study that was done, and there's been a lot of learnings that have come from it. So it's basically, the paper studies a 10-year period from 2014 to 2013, where 359 workers died in the Australian construction industry. Of these, there are 258 closed cases, of which 22 involved a crane. So we've got to look at the closed cases because that's when the facts have been determined, which sometimes doesn't happen immediately. So we need to look at the ones where we've actually determined the cause. So we look at three aspects. We look at immediate circumstances, shaping factors, and originating influences. It's called the Lauber model, and there's three levels of accident causes that can be identified. The whole idea is to work out what the root cause of the accident is and to look at the contributing factors and the originating influences. That makes you, I guess, better understand what's really going on and what you need to do to make things safer. So the most common type of accident is actually to be struck by load. Now, when we say accidents, for these next few slides, we're talking about where fatalities have occurred. So we've seen plenty of slides on cranes tipping over. They don't kill as many people as being struck by the load. Now, struck by the load means that you might be lifting something and it swings around and crushes someone, or the load is dropped on someone, or the load is very large and heavy and impacts something else, which then causes something to fall. So it's quite a general term, but struck by load is the most common way to cause a crane fatality. And of course, electrocution is number 2. So we've got a narrow sample size. We've got the examples we showed in the statistics of the earlier slides. So we're not talking hundreds and thousands of incidents. We've got only a small sample size, but we still feel that these numbers are quite relevant. So electrocution and struck by load are the main types of accidents. Failure of boom or rope means the rope snapped or the boom broke, or something, structural failure on the crane has occurred. And falls indicates basically someone falling from a height. Crane tipping over is an obvious one. Struck by cab or counterweight involves the crane swinging around and I guess part of the crane impacting on a person. So immediate circumstances are what's there at the time. Now, layout or space is basically the biggest issue, because when a crane comes to a building site, there's often not a lot of room at the building site. There's other work going on. There's site constraints. There's other structures being built at the same time. You don't have as much room as you want when you go to a building site with a crane. So the immediate circumstances that cause the greatest number of incidents are layout or space. Actions involves, I guess, the human factor and the competency and what was actually done, whether it was right or wrong. Equipment is an obvious one. It's equipment failure. Local hazards means, was there a generator sitting next to it, or power lines overhead? Was there an existing hazard right next to the crane, like a lake or a river or something, or a bridge? Lack of PPE is obviously important, but quite minimal. Helmets, safety glasses and gloves and steel cap boots, they don't cause that many fatalities, not compared to the earlier examples. And of course, the weather can be an issue as well. So originating influences is an interesting one, because it sort of takes a step back. And we can see here risk management, construction process and safety culture, permanent design and project management. So risk management basically means your comprehension of the lack of space and what you've decided to do about it, or your comprehension of an existing hazard nearby and how you're choosing to handle that while you get the job done that you're being paid to do. Because obviously, every building has to be completed. Every job has to be finished. So if there are hazards there, they get done. Things still happen. And the reason they happen is what's called risk management, which means things have been put in place. Someone's made a decision. They've altered what they've done. They've changed the way they've operated in order to make an unsafe environment safe. So risk management, or in this case, lack thereof, is one of the largest originating influences for a crane accident. And of course, construction process is the order in which you're building things and the way things are built. That's a huge factor as well when it comes to managing the originating influences. Shaping factors is factors that are involved around a construction site or anywhere a crane's operating that basically contribute to what's happening. So site constraint is huge. The design, the knowledge, the skill of the worker, and the amount of supervision. So again, site constraint has rated the highest, which indicates that a lot of crane work is being done with a lot of constraints and limitations. So it means that the crane is not operating in its most ideal form. It's had to adjust. They've had to do something different. They've had to revise their lift plan. They've had to make some considerations. So the summary is we've got struck by load and electrocution, the most common incidents that involve the most common forms of fatality, struck by load and electrocution. Most incidents involve heavy loads, usually concrete. So this is all from the report. And although the crane tip-over incidents get high exposure, they are not the main cause of fatalities. It's the site constraints and poor risk management that work together to cause the incidents. So what this leads to is risk management, because site constraints are always going to be there. So it's the way risks are managed that seems to be the main contributing factor. So whether there's complacency or cutting corners, ignoring hazards, it could be any of those reasons why fatalities are occurring. But we now know that it's the constraints of the site factored in with the amount of risk management that's happening. So what programs does the Crane Industry Council of Australia have to combat this? We've got Crane Safe, which it's a program that ensures cranes are in safe working order. We've got a Crew Safe program, which ensures workers' competency is verified. I release safety bulletins distributed regularly and communicate safety messages. It's just hidden a bit behind the sign there. Lift planning tools, ground pressure application. So ground pressure is a mobile app that you can calculate what sort of ground pressure you're dealing with and what you need to put under the outriggers of the crane to ensure that you've got adequate support for the crane on the type of ground. Technical guidance papers are released by SICA as well, and we have regular meetings with WorkSafe and the CFMEU. So an example of technical guidance papers here, we've got the effect of wind on cranes, we've got ground pressure, and we've now got a mobile app that helps you calculate the stability of the crane and how many timbers or the size of the mat required underneath the outrigger in order to stop it from sinking into the ground. And we've also got a position paper on cranes used for demolition work. So the Crew Safe program, I'm just going to show a short video on that.
The Australian crane industry is a service industry that works hard to ensure their cranes and people are up to date with the latest requirements. They strive to be efficient service providers for the benefit of all involved. As we continue to excel in our area of expertise, it is critical we drive the highest standards across the industry. This includes the competence, safety, and excellence of our crane operators. When a crane arrives on site, how do you know the operator is competent to operate? You can check they hold the appropriate licenses, but does that mean that they are competent on that specific crane? If you're a crane owner, how can you prove your operator is experienced on the crane you've sent them out in? This is a problem that is faced by hire crane customers and crane owners every day of the week. Currently, this issue tries to be addressed by conducting verifications of competence. Each different site may have their own VOCs they want to conduct. This is time-consuming and very costly.
G'day mate, I'm going to have to get our safety officer to run you through a VOC on this particular crane.
I did one of those on a mine site last week. Can't we just use that paperwork?
Sorry, we've got our own stuff. I've got no idea what they do, so sorry, I'm going to have to go again.
Furthermore, there are problems with the VOCs conducted as they are unregulated. There is a general lack of confidence in their validity.
It's a nice crane. I haven't seen this model before.
Introducing the new Crew Safe portal. The Crane Industry Council of Australia have developed Crew Safe, and it is available as an online app. With the new Crew Safe online app, you can access documented evidence that will show if an operator is competent on a specific make and model of crane. It is a database that uses a standardised process to assess an operator and record evidence of competence. An assessment conducted by people who know the equipment. A system that assesses all operators equally and consistently. Crew Safe is accessible anywhere, anytime on your mobile device. This system will save time and money. It'll benefit crane owners, operators and customers. CrewSafe provides confidence in the operator's competence and will help us ensure we deliver the highest standards of safety and quality for our industry.
So the other thing Syker offers is what's called a lift planning tool, which is a online form that you can enter in the data of your crane and the load you're lifting and basically create your lift plan. A lift plan for a crane basically ensures that what you're going to lift with the crane is going to be safe and you've got a safe way of conducting that lift or manoeuvre. So we've got an online form that basically allows you to, I guess, enter in your data and ensure that everything's correct and then submit that for approval for whoever you're working for with the crane. The next program we've got is what's called Crane Safe. So while CrewSafe focuses on the operator, Crane Safe focuses on the machine. So Crane Safe is a bit like what a roadworthy check is for a car, but it's annual. So every year the crane has to be tested with a proof load. It has to pick up a known weight and hold that weight for a number of times to check the strength of the crane and its reliability and, of course, its ability compared to its specifications. So it ensures the crane works correctly and safely and predictably, and it also covers a range of roadworthy items as well for cranes driving on the road, and ensures that the chance of an incident occurring due to a defect in the crane is minimised, because this is designed to pick up any defects in the crane that have occurred annually. So we'll now look at a video of the Crane Safe program.
For over 16 years, Crane Safe has been working to improve the safety and the reliability of the crane industry. But when I speak to people about Crane Safe, they assume it's just about getting the green sticker. It's more than that.
As crane manufacturers, determining the lifetime of a mobile crane is very difficult because of the variability in lifting operations and the stresses caused on the bearing structure and its mechanisms. FEM recommends Crane Safe as a way of continuously monitoring the condition of the crane to determine if service, maintenance or repair is required.
For us, it's more than a green sticker. It's about the bigger picture. John Holland has nationally adopted the Crane Safe program to meet third-party inspection requirements as a benchmark for the industry. The Crane Safe program ensures consistency across Australia and raises the bar in terms of accountability, transparency and quality control for our cranes as well as that of our subcontractors.
The green sticker is reassuring to our clients. They know the Crane Safe brand and they are confident that our cranes are being well maintained and are safe to use when we arrive on a site. Not only that, but Crane Safe is recognised by main insurers. It's not just a green sticker, it's about making good business decisions so we remain a strong competitor in today's market.
Crane Safe meets all the Australian standard regulation, and what's more, Crane Safe is NATO approved, so we know we're accessing an internationally recognised, properly audited, high-quality assessment tool.
Crane Safe's green sticker underpins Syker's mission to be the authority for the crane industry through supporting research, resources and representation. It's more than a green sticker, it's about better outcomes for your business and for Australia's crane industry.
So the result of the Crane Safe program, if we look at the National Roadworthiness Baseline Survey that the National Heavy Vehicle Regulator conducted a number of months ago, they went through every heavy vehicle in Australia and conducted auditing and inspections, and the cranes came up pretty good. we are pretty much the safest vehicle travelling on the road, apart from buses and coaches. We have a 3% non-compliance, and most of the non-compliance items were quite minor, such as indicator lenses cracked and flashing yellow warning lights, things like that. There are some more severe items that are checked, like steering and suspension, obviously very important for safe road travel, but the cranes have come in at only 3% non-compliant compared to up to 14% non-compliance for your average semi-trailer. And you can see they also check the brakes on trailers as well. And the cranes travelling on the road would probably be one of the safest vehicles due to the Crane Safe program and annual inspections. So that's the end of my presentation. Any questions, my email address will be provided. I guess what we've got here is an example of probably what most would call an unsafe practice. It's highly innovative, but not the smartest thing. You've got someone lifting a ride-on mower. It's not really designed for that. And you've got close proximity to power lines as well. So there you go. The main takeaways from all of this are safety has got to be something that's continuously worked on, and by all members within the crane industry, whether it's the contractors, the crane owners, the workmen, the union, the regulators, the National Heavy Vehicle Regulator and WorkSafe all need to work together to ensure that we're monitoring the safety of cranes, the incidents that are occurring, the causal factors, and doing our best to educate and alert the industry as to what's happening and what we need to do to make it safer. So thanks for your time, and we'll end the presentation now. Thank you.